Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullah. Today I select the title for description is to derive the integration formula from the derivative formulas. That is the one of the most well-known formula of integration is the power rule of integration, and I will derive this power rule of integration from the power rule of the derivative formula. On the other hand, if we know the any derivative formula of a function, then we can find the corresponding integration formula. We can find if we know the derivative formula of sine x, then we can find the integration formula of sine x. If we know the derivative formula of cos x, and similarly we can find the corresponding formula, integration formula for the cos x. And on the similar way, if we know the derivative formula of an exponential function, logarithmic function, we can find the corresponding integration formula of the required function as well. So now today I will derive in this lecture the integration power rule formula from the power rule formula of the derivative of the function. So consider the integral of x raised to the power p into dx. This is x raised to the power p plus 1 divisible by p plus 1 plus any integration constant c we can be adjust. This is x power p into dx. This is equal to x power p plus 1 divided by p plus 1. This is the integration formula. But our question is that how one can prove this formula. This will be exist as the same as. There are the many techniques to check that whether this formula is true or not. The one of the techniques is this, differentiating this result. And if we can regard this result, that mean that x power p, then we can say that the integration of this function is true. I once again recall my statement: differentiating this result, obtaining result, and if our desired result is become as a given function x power p, then we can say that this integration formula is true. But the question is that how we can find this formula as well. Then we can check that whether it is true or not. But the first question is this: how can we find this formula as well? So I will prove it from the derivation formula. Is we know that d by dx of x raised to the power p plus 1, this is p plus 1 into x raised to the power p. I write the derivative formula, derivative power rule, that is x power p plus 1 is equal to p plus 1. So shifting the power on the side and also reducing the 1 time as a power on exponent. So this is the formula of the derivative for power. And every one of you know that how this formula occurs. You can find if we take y equal to x power p and then use the definition of the derivative of the function, and then you can find this formula as well. And now I write this as d of x power p plus 1, and this is as p plus 1 into x raised to the power p into dx. And also we know that the integration and the derivative are the reverse process of each other. the integration and derivative are reverse process of each other. Or on the other hand, we can define the integration as the antiderivative. Antiderivative is called integration. Whenever the derivative and integration are combined to each other, so they always die out the effect of each other. It means to say that if there exist derivative and integration are combined to each other, then they die out to each other, then the result is always equal to 1. Therefore, by integrating both sides with respect to x, d of x power p plus 1, and this is integration of p plus 1 into x power p n dx is differential and integration are the anti to each other, therefore they die out the effect of each other, and this is become x raised to the power p plus 1, and this is a constant number we take. This is outside from the integral, and this is become x power p into dx. We know that the integration rule of this function, that is c f of x of dx, can be written as c integral of f of x in dx. And also dividing this term on this side, so x power p plus 1 divide p plus 1, this is integral of x power p into dx, and this is our desired formula, power formula of integration, power formula of integration. So this was our question, that how can we prove the power formula of integration by using the power formula of the differentiation, and this result can be extended to the every integration formula. We can be derive the integration formula from each of the derivative formula. Similarly, we can find the integration formula of the sin x, cos x, tan x, secant, cosecant, and exponential and some other, also by using on the same manner as using the derivative formula, and then reordering the formulas, and then we can find the integration formulas. Thanks a lot.